Another way to classify waves is to distinguish between the direction of the propagation of the disturbance and the direction that the oscillators actually moved. There are two basic fundamental types of waves in this classification scheme. The first is called a transverse wave. In a transverse wave, for instance, you could have a bunch of oscillators like this. And one of them's attached, say, by a spring mass, and here's another spring mass, and here's another spring mass, and then, say, a fourth one. And each one of these springs masses are attached. So if you take one of these and you pull it upwards, as it oscillates up and down, it will pull on the next oscillator, which will cause it to up and down, which will pull on the next oscillator, causing it to go up and down, which will pull the next oscillator, causing it to go up and down. So the oscillations are in this direction, but the disturbance propagates this way. I'll show that in a video again of our little pulse that we send down our wave machine. A second type of wave in this classification is called a longitudinal wave. In this case, the direction of the wave propagation is parallel to the direction of the oscillators. An example of this is sound, in which you have a pressure wave. As an example, since I can't see sound, let me give you a more mechanical example. In this case, we'll put our oscillators in this direction. So if I disturb this oscillator in this direction, as this oscillator goes back and forth, he's going to pull on this spring, which is attached to the second oscillator. This will cause this oscillator to start to move, but that will pull the spring of this oscillator, which will make this oscillator move back and forth, which will pull this spring, which will cause this oscillator. So this is the direction of this oscillation, of this first oscillator, but his disturbance is propagating parallel to it as it moves from one oscillator to the second oscillator to the third to the fourth. So this is the disturbance propagation. So if the propagation of the disturbance is the same parallel direction of the oscillations, it's called longitudinal. If it's perpendicular to the disturbance, it's called transverse. Now, some things, such as waves that are sent in seismic looking for oil and gas into rock, can in fact produce both types of waves. They'll produce a transverse wave and a longitudinal wave, and the ability to then transmit that wave as it goes from one type of rock to another depends on these properties, and we can use this to actually look underground and find oil and gas. Some things are neither quite so simple as this. An example of that would be water. Let me show you a longitudinal wave using something a little bit more common called a slinky.